Hi, so for today we're going to talk about integration using partial fractions. And here we have 5 examples we're going to solve for today. And we're going to solve this as much as possible that we will understand each steps, okay? And we're going to recall our knowledge here in terms of partial fraction decomposition. Okay, you have tackled that already in your algebra, so I'm assuming that you already know this technique. Okay, for number 1, we have to find the integral of dx over x squared minus 4. So as we all know, number 1, we have dx over x squared minus 4. So we must resolve this into partial fractions. So let's take first, okay, let's set aside first the dx and the integral sign. So we have 1 over x squared minus 4 is now will be equal to, if we are going to decompose this into partial fraction, that is simply equal to a over x plus 2 plus some certain coefficient b over x minus 2. Because x squared minus 4, if we factor this out, this should be equal to x plus 2 and x minus 2. So we did not include ax plus b here because the x here has only a degree of 1. Okay? So we have resolved this already into this partial fraction. So what are we going to do is again solve for the values of this constant a and b. So how do we do that? By actually cross multiplying this term to this term. So what will happen? We have a times x squared minus 4 is equal to this. So we have x plus 2 times x minus 2 over x plus 2. Okay? So that would be our equation, plus b x plus 2 times x minus 2 over x minus 2. So we have already cross multiplied x squared minus 4, so the only term left here is already 1. Okay, so as you can see, we can cancel out this and this, of course this and this. So it turns out that 1 is equal now to a times x minus 2 plus b times x plus 2. So let's perform the distributive. So ax minus 2a plus bx plus 2b. Okay, so combining like terms, you have ax plus bx plus 2b minus 2a. So how do you know the values of x's here? So let us now try to find the values of the a and b. So what are we going to do is 1 is equals to, let's factor out x, a plus b, okay, and x plus 2b minus 2a. So here's the shortcut. How do we know the values of a and b? So we have two unknowns here, so we definitely have to have two equations here. The first equation should be, here's this one, a plus b. Okay, and that should be equal to, since it has a terms of x here, okay, and we don't have any x term here on the left side of our equation, this should be equal to 0 because we are getting the coefficient of whatever x here we have on the right and whatever x, the coefficient of x here on the left. So we don't have any x term here, so a plus b should definitely be equal to 0. And if we manipulate that, a is equals to the negative of b. That is our first equation. So how about this? So this is another equation, 2b minus 2a. And this has no x in its terms. Okay. So we can definitely say that this equation is equal to the constant. So on the left side, we have a constant value which is 1. So that should be equal to 1. Okay, so two equations, two unknowns. So we can insert the first equation to this. So a is equals to the negative of b. So that should be 2 times the negative of b is equals to 1. So negative times negative, that should become 2b. So 2b plus 2b will become 4b. And Viola, we have b is equals to 1 over 4. Okay, that's the value of our b. And actually a is the negative of b. So we have a is negative 1/4. So these are the values of our a and b. And definitely, we will go back to our equation in here. Okay, this equation. So we have what? To find the integral of the a, negative 1 over 4 dx over, what do we have here? X plus 2, okay, plus, okay, the integral of 1/4 dx over x minus 2. So that should be now our integral. So we can calculate that. Okay, so we all know that we can factor out the constant outside of the integral, dx over x plus 2. Then we have to factor out 1/4 outside of the integral. We have dx x minus 2. So evaluating the integral of this, simply we have negative 1/4, that is an ln. ln of the absolute value of x plus 2 plus 1/4 the ln of the absolute value of x minus 2. Don't forget plus c. So this should be our answer using integration by partial fractions. Okay, so let's go now to number 2. So our number 2 question is, find the integral of x plus 1 over the x cubed plus x squared minus 6x dx. Okay, so the very first thing we're going to do here is to factor out the denominator. So what do we need to do here? X cubed plus x squared minus 6x. So that is equal to, if we factor out x, we have x squared. We have factored out x squared plus x minus 6. So this, still we can factor out this. So we have x, by factoring, we have x, okay, minus, okay, 2 times x plus 3. Okay, so this is our factor form. So again, we have 3 constants. If we decompose it into partial fractions, simply our x plus 1 over x cubed plus x squared minus 6x will now be simply equal to a over x, which is this, plus b over x minus 2, which is this, plus c over x plus 3. So again, we now have decomposed this fraction without the dx and integral sign, okay, in order for us to find what is the value of a, b, and c. Okay, so what are we going to do? X plus 1, we cross multiply this into this, okay? So what will happen? We have a times x minus 2 times x plus 3 over x, okay, plus b times x minus 2 times x plus 3 over x minus 2 plus c. I'm writing it all so that you can understand, times x minus 2 times x plus 3 over x plus 3. So as you can see here, this will cancel out. Okay, very simple. So that you are left with x plus 1, okay, a, x minus 2 times x plus 3, that is simply equal to this, okay? So we have x squared plus x minus 6, okay, plus, okay, let's try to distribute this. So we have bx squared, okay, b times x is bx times x, bx squared, plus 3bx, okay, because we have distributed bx here. So we have 3bx. Plus, we have cx squared, okay, c times x is cx times x is x squared, cx squared, minus 2cx. Okay, so what are we going to do? Still, we have to distribute this, ax squared plus ax minus 6a plus bx squared plus 3bx. Copy the whole terms, plus cx squared minus 2cx. And we're going to do what? We're going again to group this. Okay, let's get all the terms that has x squared. So we have ax squared, check. So we have plus bx squared, check, plus cx squared, okay? So that are the terms with x squared. So for now, we get also the terms with x, plus ax plus 3bx minus 2cx. Okay, we have gotten this and this. Okay, so minus 6a finally for the constant. So what are we going to do is, again, factor out the x. So we have a plus b, and that is x squared, plus a plus b plus c. I'm sorry. So we have this a plus b plus c. So a plus b plus c, that is x squared, plus a plus 3b times x. Oops, again, we have minus 2c. So minus 2c. Okay. And what is next? Times x minus 6a. So we have three unknowns, a, b, and c. We have three equations represented by this. A plus b plus c. And do we have an x squared on the left side of our equation? No, we don't have. So this should be equal to, now to what? Equal to 0. And that is our first equation. For our second equation, we have a plus 3b minus 2c. And that is in terms of x. So do we have an x here? Yes. What is the coefficient of x here? Is 1. So this must be equal to 1. Okay. Now our last equation is negative 6a. This is the constant. So do we have any constants here? Yes, and that is equal to 1. So we can simply first get the constant a. Here for the third equation, we have a is equals to negative 1 over 6. So that is the value of our a. And for b and c, what are we going to do here is, first, we can substitute a at the first equation. Okay, so we have negative 1 over 6, okay, plus, let's say, plus b is equals to, let's say, negative c. Let's get this in terms of c. Okay, so what will happen? C will become what? B, or 1 over 6 minus b. So I have applied negative sign here, negative 1. So that this equation, we can, what? We can use this for the second equation. So what are we going to do? This is simply solving a linear equation simultaneously. So we have, for the second equation from number 2, this is number 2. So a is equals to negative 1 over 6. That is plus 3b minus 2c, which is, this is the c, 1 over 6 minus b is equals to 1. So again, performing algebra, we have negative 1 over 6 plus 3b. Okay, negative 2 times 1 over 6, that is negative 1 over 3. Negative 2 times negative b is plus 2b, and that is equal to 1. By algebra, combine like terms, you have 3b plus 2b, that is 5b. Okay, 1 plus 1 over 6 plus 1 over 3. So if we simplify this, so we have 1 plus 3 plus 6 over 18. That is equivalent to 5b. So we have 5b is now equal to 1 plus 9 over 18, or simply that is 1 plus 1 half. So 1 plus 1 half is simply, we have what? 3 halves. Okay? And if we wish to get b there, okay? So what are we going to do? 3 halves over 5. So simply we have 3 halves times 1 over 5. That is 3 over 10. Okay? So our value for b is 3 over 10. So in order for us to get c, we can use this equation. Okay? So again, c will be the 1/6 minus the b, which is 3 over 10. So the c now will become negative 2 over 15. Okay? So negative 2 over 15. Okay, how did that happen? So we have 10 minus 18 over 60. So we cross multiply this and we multiply this denominator. So we have negative 8 over 60. And if you simplify this, divide this both sides by 4, you will get negative 2 over 15. So that ends our getting the unknowns. So what are we going to do next? So we are going to apply the integration. Okay? So our integral now will become the fraction a while ago. So we have what? The integral of x plus 1 over x cubed plus x squared minus 6x is now equal to what? The integral of the a, negative 1 over 6 dx over, of course, x, plus the integral of b, the value of b. What is the value of our b? 3 over 10. So we have 3 over 10 dx over x minus 2 minus, okay, because the sign of the our value for c is negative 2 over 15. So we have the integral of let's say plus, still plus, negative 2 over 15 dx over x plus 3. So if we simplify that, we know that we can factor out or put the constants along with its sign outside the integral. So we have negative 1 over 6 integral of dx over x plus 3 over 10 integral of dx over x minus 2 minus 2 over 15 integral of dx over x plus 3. Okay, if we integrate this, so what will happen if we integrate? So this is simply du over u. So we have negative 1 over 6. We have ln of the absolute value of x plus 3 over 10. Integrate this. Still, that is the ln of x, absolute value of x minus 2, minus 2 over 15. Integrate this. We have ln absolute value of x plus 3 plus, of course, the constant of integration c. So we have now the answer to our integral, which is this. Right? So let's go now to number 3. For number 3, our given is to find the integral of the 3x plus 5. Okay, so we have 3x plus 5 dx over x cubed minus x squared minus x plus 1. Okay, so how do we find the integral of that? By partial fraction. Again, the first step is we are going to factor out the denominator. Okay, so what's the factor of this? If you're going to look at this, this has a cubic function and a squared function. So definitely, okay, we can split this out as x plus 1. Let's try x plus 1 times x minus 1. So squared. Okay, should we try that? Should we check? X minus 1 squared is x squared minus 2x plus 1. Multiply that by x plus 1 because all of the terms here are in terms of coefficient of 1 or negative 1. So we might as well try this factor. So we have x squared times x is x cubed. X squared times 1 is plus x squared. Negative 2x times x is negative 2x squared. Negative 2x times 1 is negative 2x here. So we have 1 times x, if that is plus x. 1 times 1, that is plus 1. So we simplify here, x cubed, x squared minus 2x squared, that is minus x squared. Negative 2x plus x is simply minus x plus 1. Viola, we got the correct factoring, right? So this is the factor now. Okay, so as you can see here, we have a repeating root, of course, and still our x here, x values here does not have any square in it. So still, we can say that 3x plus 5, okay, the partial fraction decomposition of this function should be equal to, okay, let's not write dx first. So that should be equal to, again, this is one factor, that is a over x plus 1 plus b over x minus 1, okay, plus, again, the c over x minus 1 squared. Okay, so again, cross-multiply this into this, okay? We're going to cross-multiply all of this equation on the right side of our equation here. So what will happen? We are left with 3x plus 5 in here, so that we have a times x plus 1. So this equation or term is equal simply to this. So we have x minus 1 squared over x plus 1 plus b times x plus 1 times x minus 1 squared over x minus 1 plus c times x plus 1 times x minus 1 squared over x minus 1 squared. So as you can see, this would cancel out. So we have x minus 1 here, 1x minus 1 will cancel out here, x minus 1 squared will cancel in here. So our goal again is to find the values of our unknowns, which are the a, b, and c. So we have a times x minus 1 squared plus b times x plus 1 times x minus 1 plus c times x plus 1. Again, we can distribute it again. So we have, this is actually x squared minus 2x plus 1. So x squared times a, that is ax squared, minus 2x times a, that is negative 2ax. The whole term, plus 1, simply plus a. And this plus is simply x squared minus 1, if I'm not mistaken. So x plus 1 times x minus 1 is simply x squared minus 1. So if we multiply b by x squared minus 1, it should be plus bx squared minus 1 minus b. Okay? So that's it. So distribute this plus cx plus c. And again, we will group them according to their power of x. So we have ax squared plus bx squared. Okay. So then we have, for x's, we have, let's write this first, cx minus 2ax. And for the constants, we have a plus a minus b here plus c. And we are going to factor out the x's. Okay. We have x squared here plus we have c minus 2a, that is equivalent to x, and plus a minus b plus c. So how many unknowns do we have here? Okay, how many unknowns do we have here? We have 3 unknowns, so we have to have 3 equations here. So the first equation is a plus b. Now my question is, a plus b is equal to what? This has an x squared, okay, x here. So we don't have any x squared term on the left side, so this must be equal to 0. That's our first equation. Our second equation is this, c minus 2a. So c minus 2a, so it is in terms of x. So do we have an x here? Yes, we have 3x here. But what are we going to get is only the coefficient. So we have c minus 2a is simply equal to, yes, that's right, that's 3. Okay, and a minus b plus c, that's our third equation. That is a constant. So do you have a constant value here? Yes, that is equivalent to 5. And we can solve now a, b, and c because we have 3 equations, 3 unknowns. So we can have here a is equals to negative of b, or simply we can get this in terms of a. So b will now be equal to negative of a. And here we can get this in terms of c. So we have c is equals to 3 plus 2a. So that we have what? We can express all of this in the third equation in terms of a. And we can substitute b here. We can substitute c here in terms of a. So this equation and this equation, we can substitute it here. So what will happen? We have a minus b. What is the minus b? B is equal to negative of a. So that is negative of a. Okay. Plus c, which is plus 3 plus 2a. Okay, so equals to 5. So this is simply our A, this is simply our B, the negative of B, and this is our C. So we can get A. So we have A negative minus the negative of A plus A plus 3 plus 2A is equals to 5. So what are we going to do? We have 2A plus 2A, 5 minus 3 here. We have transpose T on the other side. So we have 4A is equals to 2. Okay, and our A is equals to 1/2. Well, of course. So that is our A. And going back to our equation, we can get B here. And simply, according to this equation, okay, we have derived from the first equation, B is simply equal to the negative of A. So what is the negative of A? The negative of A is simply negative 1/2. So that is our P. Okay? And how about for C? We can use this equation. So C is equal to 3 plus 2A. So C now will become 3 plus 2 times A, which is 1/2. Okay? So twice of 1/2 is equal to 1. So what are we going to do here is 3 plus 1 is equals to 4. So we now get the values of A, B, and C. So we can therefore now solve for the integral of our given, which is 3x plus 5 over the x cubed minus x squared minus x plus 1 dx, and that is simply equal to the integral of A, which is 1/2 dx over, okay, over x plus 1, okay, and plus the integral of what is the value of B, that is negative 1/2 dx over, okay, x minus 1. So our denominator here is the same as what we get in the partial fraction decomposition here. Okay, so we have this equation now plus, okay, the integral of C. What's the value of C? That is 4 dx over, okay, x minus 1 squared. So again, by principle, we can factor out, or we can factor out the 1/2 or the constants outside of the integral, so that we have 1/2 dx over x plus 1 minus 1/2 the integral of dx over x minus 1 plus 4 the integral of dx over x minus 1 squared here. So we can have the integral of this simply, that is 1/2. Yes, of course, that is du over u, that is ln of the absolute value of x plus 1 minus 1/2. Again, if we integrate this, that's equivalent to the natural logarithm of the positive, our absolute value of x minus 1. Okay, here we cannot use ln because it's raised to square number. So what are we going to do here is we let u as equal to x minus 1, okay, squared, okay, x minus 1, no, x minus 1 simply, then we get the derivative of that, okay, simply the du is equal to dx. So we can substitute u here. So what will we do is for the integral of the du here over the u squared. So what I'm going to do here is to find the integral of this, we can bring this up. So we have u raised to negative 2 times the du. Okay, so what will happen here is simply integrate this. We have 4, if we integrate this, we plus 1 here. So we have u raised to negative 1 over negative 1 in here. Okay, so what will happen is this is positive, divided by the negative, so that should be negative 4. So what will happen, we can bring down what? Negative 4, 1 over u. Okay, so this is our resulting integral. So what will happen here? Okay, so in other words, negative 4 over what is u? That is equal to x minus 1. Okay, so let's not forget we have the plus c. So after this, So our answer here should be negative 4 or minus 4. Okay, minus 4. Let me just rewrite it. So minus 4 over x minus 1 plus c. So this is a minus sign because of the negative, because we have divided it into negative 1 here. Okay. So that's it. That's it for number 3, I guess. Okay. That's for number 3. So for number 4, we have to find the integral of the x cubed. Okay. Need to find the integral of x cubed plus x squared. That is the same example a while ago. Okay, dx over what I have shown you on the first part of this video, over x raised to 4 plus 3x squared plus 2. Okay, the very first thing, again, if we are going to integrate this using partial fractions, we should be able to factor out the denominator, x raised to 4 plus 3x squared plus 2. And in order for us to factor that, remember we have x raised to 4. So it must have a factor that has x squared. And I believe that is purely plus. Okay? So x squared here. So we have x squared here. Okay. So it has a plus sign on the second term. So definitely we should have a plus sign here. So let's try x squared plus 1 and x squared plus, let's say, 2. Of course. So, okay, are we correct? So if we FOIL method this, we should be arriving at this answer. Okay, FOIL x raised to 4, that's correct. Outer x squared plus 2x squared plus x squared, that is 3x squared, and 1 times 2, that is 2. So we got the correct factor here. Okay, and since now this is raised to the second degree, so if we reduce this into partial fraction, let's say x cubed, okay, x cubed plus x squared plus x plus 2 over x raised to 4 plus 3x squared plus 2. If we reduce this to partial fractions, since it has a square in it, so that should not be equal to simply a, but rather ax plus b. So that is in the lessons of partial fraction. X squared plus 1 plus, okay, we have the cx plus d over x squared plus 2. So we have now 4 unknowns still, and we have to find 4 equations to get A, B, C, D. So because that is our concern. So what are we going to do again? If we cross multiply this, so we are left with the equation here on the left side as x cubed plus x squared plus x plus 2. Okay, so we have ax plus b multiplied by simply this. So this is equal to this. So we have x squared plus 1 times x squared plus 2 over the x squared plus 1 plus cx plus d. So we have here still x squared plus 1 times x squared plus 2 over x squared plus 2. And we can see that we can cancel this out. Okay. Okay. So we are left with x cubed here plus x squared plus x plus 2 is equal to ax plus b. Multiply that by x squared plus 2 plus cx plus d multiplied by that x squared plus 1. So upon performing, okay, FOIL method, let's try to perform FOIL method in order for us to simplify the this. So we have first ax times x squared, that is ax cubed. We have the outer ax times 2 is 2ax. We have the inner plus bx squared. We have the last, that is plus 2b. And here we still perform FOIL. First, we have cx times x squared, that's cx cubed. Outer, that is plus cx inner plus dx squared. Last plus d. 1 times d is d. So again, the same process, we're going to regroup the x's from the highest term. We have ax cubed plus cx cubed. Do we have any other? Okay, cube, no. So next is the x squared plus px squared plus dx squared. Okay, next is the x's. So we have plus 2ax. Okay, and what do we have? Plus cx. And next is the constant. So we have 2b plus d. Plus 2b plus d. And again, we can factor out the x's again. So we have a plus c. That is equivalent to x cubed. Plus b plus d. We can factor out x squared. And here we can factor out x, 2a plus c. That is x plus 2b plus d. And here are the equations. So we have a plus c, x cubed. Do we have an x cubed on the left side? Yes. What's the coefficient? That is 1. So a plus c is equals to 1. Okay, that's our first equation. Okay, the other one is b plus d. So we have x squared here. So do we have an x squared here? Yes. The coefficient is 1. So that is equivalent to equation number 2. So we have 2a plus c is equals to, we have here an x. So we have here an x. The coefficient of x here is 1. Okay. And lastly, this is our equation 3. And lastly, we have 2b. Okay. 2b plus d. Okay. And 2b plus d. Okay. This is 2b plus d is equal now to the constant, which is 2. So this is our fourth equation. Okay. So as you can see here, we can, to find the a, b, c, and d, we can perform elimination. So if we choose equation 1, we subtract it with equation 3. We have a plus c is equals to 1. Subtracted it by equation 3. Our equation 3 is 2a plus c. So what will happen? The negative sign will be distributed. Negative 2a minus c is equals to negative 1. Okay, so what will happen to this? If you subtract, proceed to addition. So what will happen? A plus negative 2a is simply negative a. So the c's will cancel. Okay, 1 minus negative 1 or 1 plus negative 1 is simply 0. And we get an a that is equal to 0. That's okay. Okay, so that is equal to, a is equal to 0. If a is equals to 0, we can substitute this truth into equation 1. So a plus c is equals to 1. So a is 0 plus c. So therefore, c is equal to 1. Okay. Now, in order for us, again, to get the value of d, we can what? Subtract equation 2 and equation 4. So these will cancel for us to get the b. Okay. So what are we going to do here? We have equation 2 minus equation 4. So we have b plus d is equals to 1. And then equation 4, we have distributing the negative sign. We have negative 2b minus d because we have subtracted minus 2. And we're going to add. So what will happen here is the result should be what? B minus 2b is negative b. So we have cancelled the d. So 1 plus negative 2 is simply negative 1. So we can get the value of b as d1. Okay? So that is equivalent to 1. So if we get the value of b, we can substitute it on the second equation, which is b plus d is equals to 1. So what will happen? B plus d is equals to 1. So we know that b is 1 plus d is equals to 1. So d is equals to 1 minus 1. D is now equal to 0. So we now get all the values of the a, b, c, and d. So with a and d having 0, but b and c is equal to 1. So if we go back now to our original equation, okay, for our original equation, so we have x, the integral of x cubed plus x squared plus x plus 2 over the x raised to 4 plus 3x squared plus 2 dx. That is equivalent to what? AXB. Okay, so let me just rewrite again. AXB over x squared plus 1 plus CX plus D over x squared plus 2. Wherein, okay, we have to integrate this. Wherein our values, okay, let's not forget the x here. Wherein our values of A, B, and C, D, we have already got the constant values. So, we're going to substitute it here. So, what will happen? Okay, so what will happen in here? So, we have A is now equal to 0. Okay, so if it is equal to 0, we have no choice, but we are left with B. So, we have A is equal to 0, so we have B is equal to 1. So, that is simply dx over x squared plus 1. Plus the integral of cx, okay? We know the value of c is 1. So 1 times x is x plus d, which is equal to 0. So we are left with this equation. Okay, so how do we integrate? The final question is, how do we integrate this? Okay, x squared plus 1 plus the integral of x dx over x squared plus 2. How do we integrate that? For the first, okay, you cannot use ln because it has a square, but this is an integral yielding to inverse trigonometric function or arctan, arcsine, arccosine. So in this case, this is an arctan, okay, and we have 1 over a arctan over x times over a, where a here is the value of the constant. In this case, okay, so if we get the integral of dx over x squared plus a squared, it should be equal to 1 over a arctan x over a. So, if this is 1, okay, this is the a squared, so we get the a, that is simply 1. So what will happen is 1 over 1, it's okay, it will be cancelled, okay, that is still equal to 1. So arctan over x over 1, so what will happen for this first side of our integral, so 1 over 1 arctan of x over 1, so simply that would be arctan of x, okay? This is the integral of the first. How about the second? Okay, for the second one, we can integrate this by letting u as x squared plus 1. Okay, and if you get the du, that is 2x dx. As you can see, we have x here, x dx. So we can offset 2 here, but we can offset outside of the integral 1/2. Okay, so that we would be able to say that this is an ln of x squared plus 1. Why? Because this should be the du over u. Okay, so we can now integrate that as du over u, because the du is 2x dx and the u is x squared plus 1, which is equivalent only to this, of which we have offset a value of 1/2 outside of the integral because we added or we multiplied the numerator by 2. So what can we say is we can integrate that by plus 1/2 simply ln of the u. X squared, absolute value of x squared plus 1 plus, of course, the value of c. Okay. Okay, let's proceed now to our last example. Our last example is the number 5. So we have now to find the integral of the x raised to 5 minus x raised to 4 plus 4x cubed minus 4x squared plus 8x minus 4 over the x squared plus 2 cubed dx. So, and again, this is a repeating equation or term. X squared plus 2 is simply equal to x squared plus 2 is cube is simply equal to x squared plus 2 times x squared plus 2 times x squared plus 2. But, okay, we will not write it as an ax plus b over x squared plus 2, okay? But rather, we can decompose this as let's say x raised to 5 minus x raised to 4 plus 4x cubed minus 4x squared plus 8x minus 4 over the x squared plus 2 raised to 3. So this is a repeating, okay, case. So what we have to do, since it has a square, the x here is raised to 2. So we have ax plus b over x squared plus 2 plus cx plus d over x squared plus 2 squared plus ex plus f over x squared plus 2 raised to cube. So that would be our partial fraction decomposition. So again, if I'm going to multiply this by this, so what will happen? Okay, let me just rewrite again this term. Probably later, again, I will write this. So what will happen? X squared plus 2 cube over x squared plus 2. So what will happen is ax plus b. Okay, so simply, this would become x squared plus 2 squared. Okay, I hope you get what I'm trying to say. Plus cx plus d. Multiply it by this. Okay, x squared plus 2 cube over x squared plus 2 squared. So the 2's will cancel. So we are left with x squared plus 2. Okay, and finally, if we multiply this into this, so simply the x squared plus 2 cube will cancel itself with this denominator. So simply we are left with ex plus f. And what are we going to do? What are we going to do here is to find again the values of a, b, c, d, e, f. So a, b, c, d, e, f. So we need 6 equations here. So what are we going to do? Okay, so ax plus b. Let's evaluate this. So x raised to 4 plus 2 times x squared, 2x squared times 2 plus 4x squared. Okay, x raised to 2, that is 2 raised to 2 is that is equivalent to 4. Okay, let's multiply this foil. So if we foil this first, cx cubed outer plus 2cx inner plus dx squared, and last plus 2d again plus ex plus f. And if we're going to distribute this ax plus b by multiplication, we have, let's start with ax times x4, that is ax raised to 5 plus 4ax cubed. Okay, ax times 4x squared, okay, times ax times 4, that is plus 4ax, and again bx raised to 4, b times 4x squared, that is 4bx squared. Finally, b times 4, that is plus 4b. And we have cx cubed plus 2cx plus dx squared. It's quite lengthy, okay? Okay, but if you got used to it, if you get to be used to it, solving this integral by partial fractions, then it would be really easy for you. So again, let's group these terms. So we have ax raised to 5. Okay, for 4 raised to 4, we have plus bx raised to 4. So this is our done terms. So we have x cubed plus 4ax cubed. Okay, we have here, and we have here cx cubed. Okay, and how about for the x squared? We have 4bx squared plus dx squared. Okay, plus the x. So we have 4ax and 2cx plus 2cx plus ex. Okay. Again, the constant, that is plus. So do we have a constant? 4b. So we have 4b plus 2d plus f. Okay. So if you factor this out, so we have ax raised to 5 plus bx raised to 4 plus 4a plus c x cubed plus 4b plus d, that is x squared. Factor out x, 4a plus 2c plus e, that is equivalent to x. And our constant simply is plus 4b plus 2d plus f. So as you can see now, we have 1, 2, 3, 4, 5, 6 equations because we have 6 unknowns. And this is actually equal to x raised to 5 minus x raised to 4 plus 4x cubed minus 4x squared, okay, plus 8x minus 4. Okay, that is equivalent to this. Okay, so our first equation is A. Okay, do we have an x raised to 5 on the left side? Yes, we have. That is equivalent to 1. That simply A is equals to 1. And B, x raised to 4 is simply negative 1 because the coefficient of x raised to 4 here is negative 1. Okay, how about 4 cube? So we have 4a plus c. This is in terms of cube. So we have a cube here. That should be the coefficient of cube on the left side. X cubed is 4. So that must be equal to 4. And how about for x squared? 4b plus d. X squared do we have? So the coefficient is negative 4. Okay, for 4a plus 2c plus e with an x here. So do we have an x here? So the coefficient is 8. So that should be equal to 8. And lastly, 4b plus 2d plus f is equal now to, do we have a constant? Yes, that is equal to negative 4. And again, okay, using this a and b, okay, we can compute for c, d, e, and f. So we can substitute a here. So 4 times 1 plus c is equals to 4. So if this 4 plus c is equals to 4, then definitely c is equals to 0. Okay, and again, we can use this b on the fourth equation. So substituting that, so we have 4 times the b, which is negative 1, plus d is equals to negative 4. So this is negative 4 plus d is equals to negative 4, and d again is equals to 0. Again, using this 4 known a, b, c, and d, we can substitute it here to get e. So for e, so we have 4a, 4 times 1 plus 2 times 0. Here we are solving this. Plus e is equals to 8. So that should be what? So e should now be equal to 8 minus 4. So our e now is equal to 4. So this is our e. E is equals to 4. How about the f? Okay, again using the previous known values. So we have 4b. 4b is negative 1 plus 2 times 0 plus f is equals to negative 4. So this should be 0. Negative 4 plus f is equals to negative 4. And again, the value of our f here is equals to 0. So we have now the values. Okay. So simply the integral of x raised to 5 minus x raised to 4 plus 4x cubed minus 4x squared plus 8x minus 4, and we have an x squared plus 3 cubed, okay, simply equal to the integral of what? Do we have an a value? The value of our a is x, okay? Ax plus b, what is the value of b? That is negative 1. So ax plus b simply will be x minus 1. This is the value. We have a constant coefficient a here. Okay, we have 1. So it is ax plus b. So we have 1x, or simply x, minus b. Okay, so the value of our b is negative 1. So we have a minus 1 here. Okay, this is dx over, of course, x squared plus 2. And again, plus cx plus d. What is the value of our c? C is 0, so we don't have any x here. And d is also 0, so the term cx plus d is simply equal to 0 because it has a 0 numerator. And lastly, for e and f, so ex plus f, so we have 4x plus f is equal to 0, or divided by x squared plus 2 raised to, well, of course, 3. So if you are actually thinking how or did we get this is because we simply substituted it into this equation. Okay, this equation. And we put an integral and dx. So that this term is 0 because c and d are both equal to 0. Okay? So, again, okay, let's integrate. So, this function, we can simply separate this. We have x over x squared plus 2 minus the integral of dx over x squared plus 2. Okay? Plus the 4 integral of x over x squared plus 2 cubed. Okay, so we have here dx also, x dx. So again, we can integrate this by, we have to set x squared plus 2 as u. To get du, we have 2x dx, and we have x dx here, so we can offset 2 here and offset 1/2 here, so that this would become 1/2 of the ln of the absolute value of x squared plus 2. And this, again, actually, is what? This is, again, an arctan, okay? X squared dx over x squared plus 2. So, again, our a here is actually the square root of 2 because our a squared is equal to 2. So, if you get this, 1 over a, arctan of x over a. So, 1 over a is square root of 2, 1 over square root of 2, then we can rationalize this by multiplying this denominator and numerator by square root of 2. So we have square root of 2 over 2, and then arctan of x over a. So what is our x? That is simply x. What is our a? That is square root of 2. Okay, so we can simply have this, okay, inside the arctan. Okay, so that should be, this should be the integral of the second term. So we have now minus square root of 2 over 2, the arctan of x over square root of 2. Okay? Plus, again, what will happen here? How can we integrate this? Again, by u substitution. So we can choose u as x squared plus 2. Du is, we have 2x dx. So what will happen here is simply, okay, we have to offset, we have to have 2 here, and we have to divide this by 2. This simply becomes 2. Okay? Okay? So what will happen is, if you're going to, what do you call this? If you're going to substitute it with the u substitution, the answer should be, okay, this would become minus, okay, this would become minus because we have used the u substitution here, minus 1 over x squared plus 2 raised to 2, okay, plus c. Okay, so how did that happen? Because we have here, let's focus on this. So we have the integral, just for you to understand. So we have x, the dx over x squared plus 2 raised to cube. And that is, we have 2 here. Or we have 4 here, and my mistake. So we have 4 here. Okay, so I have 4 here. So what happened is that we let u as equal to x squared plus 2. Du is simply 2x dx. So what we did is we offset 2 here, then we divide this by 2, then simply this become 2. And what will happen? We will integrate now. This is du, and this is u cubed. So in order for us to integrate that, we have u raised to negative 3 times du. Okay, so if we integrate this, so we know that this should be equal to u raised to negative 2 over negative 2 plus c. So this would cancel, leaving a negative sign here. So we have 1 over u squared plus c. So simply, our u is now equal to negative 1 over our u here, back substitution. So we have x squared plus 2 squared plus c. So what will happen is this. So we have a negative here. So this should be our final answer for our integral here. Okay? So, and I hope you find this video helpful. Thank you so much for listening. This is integration using partial fractions. Thank you so much, and don't forget to subscribe on my channel. Thank you and God bless.